What's up, guys? It's Mr. Ernst. I saw you guys were having some trouble with this assignment, so I'm going to be coming in to kind of help you out with what we're doing here. So we are starting to work with functions, which look like this, f of x. That's how it's kind of pronounced, is f of x. And truth be told, we've actually been working with functions all year. They just have looked like different things. Y is equal to mx plus b is a function. Y is equal to m to the power of x is a function. Y is equal to x to the power of 2 is a function. Linear, exponential, quadratic. These are all functions. The only difference between what we've been doing before and what we're going to be doing this unit is that instead of having a y at this far point over here, we are now going to say f of x is equal to mx plus b. F of x is equal to m to the power of x, and f of x is equal to x squared. These still function the same way that they have the entire time that we've been doing them. You have your input, which is your x, and you have your output, which is now f of x, function of x. Think of function as kind of a box or a machine, a special machine. You take x, which is your input, you put the x value into the machine, f of x, and then the machine gives you a y value. So in the case of, let's say, a linear equation, rewrite this real quick because I scribbled all over it, let's do f of x is equal to, let's say, let's just say 2 times x. If this value, the x, was actually, let's say, 3, my output, my input would be 3. 3 is my input. My output would be 6. Kind of thing. Okay? So it's kind of the same stuff that we've been working on this year so far. Going through, let's do the first couple of problems together. So in this first problem over here, we have, so it tells you for each of the following examples, describe a domain, and a range that makes sense for the function. The domain is basically which x values will work for that function, and for example, range is which y values will work for that function. Or in other words, what inputs and what outputs work for that function. Some functions, for example, like a linear line, go on into infinity. They don't stop. So in other words, they're going to continue on forever in both directions, which means all x's would be your domain and all y values. You can have any x value and any y value in your domain and range. And that's exactly what we have for this first problem. This problem here is in slope-intercept form. This is mx plus b. Our m value is 1.5, x is just x, and our b value is -4, which means that this is going to be an equation that starts about at -4, and then it has a positive slope, so it's going to increase. It's a lower number, so this is going to increase kind of slowly. This is going to have all x's and all y's. There's nothing that stops it. Not all graphs do this, though. For example, we talked about quadratic graphs, and a quadratic graph will not have all y's. The range is not going to be all y's because at some point on the quadratic graph, it gets to its lowest point. In other words, it's no longer going to be able to hit any of the values that are down here because it's hit its lowest point. So in other words, your y value or your range instead would be something like, let's say this was 3, y is greater than 3, and that would be your range. Domain, because this technically does go up in both directions for forever, your domain would still be all x's. So the problems A, 1a, 2a, and 3a are asking you to describe what are the domain and range. What are the domain and range? What are the domain and range? We just did the first one. The very first one is y is equal to mx plus b. This problem goes off into infinity. So domain, all x's, and range is all y's. There's no limits. Everyone is included. Cool? That is just for the a's of each of these. We'll go through and do all the other letters now. Again, the nice thing about this being a video, if you need to go back and look at any parts, you can just go ahead and rewind the video. I'm going to erase a lot of stuff to make this a little bit easier to see. All right. So, back to this. These problems down here is basically, we have this problem here, which again is essentially y is equal to 1.5x minus 4. Again, the only difference is now that this is now f of x. What you're being given down here is either the input, which is the x value here, that's why it's f of x. This is your input value, and this is your output value. So you're either given an x value, or, for example, this one down here, you're given a y value. So x value and y value. Once you have that, you're basically just plugging it into the equation and solving for the other variable. So let's do b first. B says that the input value, x, is 3. So I simply replace this with 3. And now I solve. 1.5 multiplied by 3 should be 4.5? I think. Is that right? Yeah, 4.5. Minus 4. I actually might be wrong on that. I'm going to double check. I don't want to be wrong on a video. 1.5 multiplied by 3 is, yes, okay. I have test taker brain where I got to check even simple math. So now we have 4.5 minus 4 gives us 0.5. And that would be your answer for question B. Or in other words, again, when we replace, if we input 3, the output was 0.5. This is our x value, and this is our y value. Now I'm going to move on to the second one. Again, purpose of this is it's a video, so if you guys need to go back or move forward or skip ahead, go ahead. Second problem, f is -2. Again, this is an x value. So once again, I have y is equal to 1.5x minus 4. My x value is going to be -2. So all I'm doing is replacing this x value with -2. This turns into a -3 minus 4 is equal to, this is, I'm sorry, this, I forgot to replace this. This is f of x now. Is equal to -3 minus 4, which means f of -2 is equal to -7. So f of -2 is equal to -7. Problem D. This is the first one that does not give us the x value. So I'm going to rewind this. Restore my original equation here. This one does not give us our x value, but instead gives us what the output is, y. So in other words, we know that f of something is going to give us an output of 5. So I'm going to erase this, and I'm going to put in 5. What value, what input is going to give me a value of 5? So I've got to figure this out. From here, I'm probably just going to get rid of this 4, adding 4 to both sides. These cancel out. This turns into a 9. So this will be 9 is equal to 1.5x. Divide both sides by 1.5. 9 divided by 1.5, once again I'm going to pull out the calculator just to be sure I'm giving you guys the right answer. 9 divided by 1.5 is equal to 6. 6. So I know my input, f of x, if I input 6 into this function, I'm going to get the number 5. If I input 6 into this function, I'm going to get the number 5. So this answer here is 6. This pattern you're going to follow basically all the way through. Okay? With these two, because it does get a little bit weird towards the bottom, -4. With these two, this one is just asking you to rewrite the equation, but instead of an x, it will be with an n. That's about as simplified as you can make it. You can't simplify it anymore, and so that would be the answer to F. For letter G, this entire thing is my input this time, x plus 1, which means I'm going to erase the n, and I'm going to put the entire thing in there, x plus 1. Then you just go through and solve it as per usual. Make sure you distribute everything out and go from there. I'll let you guys solve the rest of that one. Each one of these problems is done exactly the same way. This says it's g of x, and all that means is that this is a different function than this, as is this one. F is almost always the first function that you'll use. Then you'll have g, h, I, if you're really getting crazy with all that stuff. Each one of these is just a different function. Each one of these works exactly the same. Cool? For these ones, again, for problem A, if you guys don't know what this graph is going to look like, you can always put it into Desmos and see what Desmos shows you. Again, you're looking for the domain, which is your x values, and your range, which is your y values. All of these problems down here are solved the exact same way. So as an example, for this first one, G, we have g of x is equal to the square root of x. Our input, our x value, is 9, which means I'm going to erase my x's. 9 and 9. It's pretty simple. G of 9 is equal to, what's the square root of 9? Comes out to be 3. So that would be my answer. Cool? Again, you guys have done almost all of this stuff beforehand, at least all of these problems. The problems that are right here, and right here, and right here, all of these problems you guys have done before. The domain and range is really the only new content you're looking at right now in these things, okay? I hope this helps you guys out a little bit with this first question. The other two I think might come a little bit easier once you've practiced with these first A1, A2, and A3. If you guys do still have questions, please feel free to stop by at one of my office hours and ask me for a specific question, and I can help walk you through it, okay? Good luck. Miss you guys. Take care of yourselves. Bye.